So if you really look at it, what we call the productivity pyramid in a factory, basically you start at the base level and you keep moving up in terms of control levels, and then it should be, it go to the highest level. The information, like in any hierarchy, like in any organization, actually the information flows upwards and instruction moves downwards. Therefore, the higher level instructs what the lower level should do, and the lower level keeps giving the information. Communication enables machine and information to work together, and obviously the communication unifies all the machines and give you the data that you require. Next. So if you really look at it, this in crux gives you the entire, actually in a nutshell, the industrial automation that operates in a plant. There is a device layer, there is a control layer, there is an information layer, and it all links up and are very well connected, and through different levels of control. Just to give you a small hint about how, just to give you some real life example, this is a paper machine. I'm sure, of course, none of you would have seen a paper machine, but in paper machine what really happens is that you have pulp which is made, and then it goes through a paper machine basically. Each machine actually has got different, again, levels. It starts from being pulp, then slowly it solidifies, and then that's known as the wet area, and then it gets into a dryer where it is dried up. Slowly it moves through a list of conveyors where it dries up, and then finally, it is ironed, what is known as a calendar, and then pop reel where it actually reels, the paper reels. Now this paper is taken, cut into sizes, and then finally, it is sent out in the market for selling. Therefore, here lots of these motors are running, lots of these PLCs are involved. So you will find all of these connected there at the bottom level, and each one of them, having a process, being interconnected, and they move up, as I have shown you in the earlier case. We have got, going to the process level, and then finally at the factory management level. And now, of course, the latest technology allows you the information from the plant to go to the corporate headquarters, from where instructions can come. They can change the production schedule, they can change, any schedule they want within the plant to cater to the requirements of the customer. So actually, some of the misconceptions I would say about industrial automation, which I used to find, people say, it's not, it's not IT. It's not IT because we want to go to IT. But actually speaking, it's IT and more. A lot of IT is involved in it. In the last 10 years, tremendous amount of IT has found its way into the plant itself. It's much more than IT. The field is for electrical, electronics, computer engineers due to multidisciplinary nature. There's a huge amount of, interdisciplinary functions that are involved in it. Actually, people used to say there's not much scope in India for these. But actually, with the government pushing in Make in India, Made in India, there's going to be an explosion for the requirement of automation engineers. Any factory you start, you cannot do without automation today. And which means there's going to be a huge demand of automation engineers, which today, unfortunately, is scarce. We don't get automation engineers today. Of course, somebody said it's not challenging to the mind. But actually industrial automation encompasses these. It encompasses transformer design, power system engineering, embedded technology, programming, networking, HMI interfacing, business processes. It has got everything that goes into it. Therefore, it's much more multidisciplinary than any other industry. So it requires machine knowledge, it requires process know-how, it requires remembering your mathematics and physics, it requires real-time programming skills, and it requires equipment communication expertise, and incidentally, a lot of software skills. Therefore, if you really look at industrial automation as some sort of a disciplinary area in which you should be, I think, there's a huge possibility that is there. And even for people, who do mechanical engineering, a little bit of knowledge on this and a little bit of software skills. Today, every software skill is finally related with some subject connected with IT, which I think, Anant will be much better positioned to talk about it than me. But I think finally, you will find these disciplinary functions that are there will help you actually grow in the industry. And there are huge opportunities not only for engineers to come to industry and work in these type of fields. JK mentioned about entrepreneur. There's a huge possibility of entrepreneurs coming into the automation area. As I said, the amount of automation engineers that are available are very scarce compared to the demand. There's a huge gap in demand of engineers, good engineers available, that are available for the automation industry. The second factor is most of the companies that operate in the automation arena are all foreign companies. There are no Indian companies, by the way. I mean, not a single Indian company who work in the area of automation. I mean, basic automation. I mean, a lot of companies integrate, but I'm talking about basic, whether it is Siemens, whether it is ABB, whether it is Invensys, whether it is Emerson. They are all foreign companies who operate in India. And there's a huge amount of value addition that ought to be created from these basic products to what goes into the industry. And there is a huge gap in that area of value addition. That's another great opportunity for people, I mean, who are looking at automation as some sort of a career to move by. I think I'll just close it at this point and then ask for any questions I'll take. Thank you.
Thank you, sir. Such a experience, knowledge, wisdom, and the way he talked about industrial automation, I think whatever Anand in his IT or JK with regard to entrepreneurship, I think all seems to be possible in industrial automation. Thank you anyway for that. And now the floor is open for QA. I think considering the time constraint, maybe another 20 to 25 minutes maximum. I just want to tell as policy in PALS, whenever we open it up, we would like to know the college from which you are there, because that forms part of the final decision on the best PALS institute. So the floor is now open for the questions.
Myself Sanjeev Mohanty from Agni Engineering College. I have a question to Mr. Ananthan. Sir, can you tell me, in every 15 days I am meeting my mentees. They are asking me now whether IT is a emerging career. They should join in IT because the headlines came about TCS, and this, can you suggest the student whether they should go for IT and what is the problem they are facing in their career in IT, and it is prematurely it is ended. Please tell something on this.
Like I said in my address, the world of information changing quite a lot from what it was 10 years ago, 5 years ago, certainly a lot from what it was 30 years ago. It is moving into many, many new disciplines. It is moving into the engineering disciplines, it is moving into the sciences, it is moving into the human interface, it is moving into mobility, into all the digital 5 forces that I said. I think this century, 21st century, is going to be driven by information. But the nature of the applications that will be coming out are all going to be very industry specific, very domain specific, very much in the hands of much, much larger numbers of people than they were ever we thought about 15 years ago, 20 years ago. So the opportunity certainly exists. Now, what should an engineer today aspire to? Certainly the information technology, computer science, computer engineering capabilities are foundational for anybody wanting a career in computing and in an IT company. But like I think you heard from both JK as well as Ramnath Mani, there is an element of capability in computing which is there in many other fields as well. So I would encourage people who are looking at computing, information technology, or any other associated branch of engineering to keep this in mind. That you will have careers in IT, but you'll also need these capabilities in many other branches of your own domains. So in the future, you will need the domain capability, you will need the IT capability, and you will need an interdisciplinary mix and mindset of thinking. So that transition is what we are going through, and every organization, every individual has to recognize this transition. So IT is there, it will be the biggest thing in the 21st century, but it will get embedded into many, many other disciplines as well as core IT itself. So companies have realized this, individuals have realized this, academia has realized this, so each of you should keep that in mind. So if you're in an IT discipline, certainly look at information technology, become the best computer scientist you can, but don't stay restricted only to computer science. Learn the adjacent disciplines. If you are in any other branch of engineering, and Ramnath Mani summarized it beautifully in the industrial automation space, there is so much of information technology, communications technology, mechanical engineering, process engineering. That's the way in which all disciplines are thinking now. So be expert in what you are, but keep your doors and windows open for all other disciplines. That's the message I'd like to give.
My question is addressed to Mr. Anant and Mr. Krishnan. I often wonder what people in IT companies do in their work. When I ask a lot of people, they give me an outline which is very abstract. They tell me that I specialize in this field and this is being processed and all. But my question is, what do you do in your office, in your table, at the end of the day?
Which college are you from?
I'm from Rajalakshmi Engineering College.
Very apt question. So let me describe not just what I do, but let's say what a junior engineer in TCS might do, or any IT company might do, and what a senior engineer does, and so on. So there are multiple things that happen in an information technology company. There are many types of information technology companies. Some are product oriented, some are service oriented, some are consulting oriented, and so on. But by and large, at a junior level, your work day is described by a set of tasks that you will typically be given responsibility for. So those tasks could be related to designing of software, or developing the software in terms of programming code, or testing that software, or once that software has been released to some application, it could be any application, it could be a banking application, it could be an industrial automation application, it could be sending a rocket to the moon, whatever. You will have to manage that software through its usage life cycle as well. Right? So as a junior engineer, your tasks are usually around this, what is called the software life cycle. Conceptualize it, actually build it, write it, test it, release it, and manage it in production. As you become expert at each one of these, maybe more than one of these in your tasks, then you get to many different career paths. You can possibly be a person who interfaces with the end user. So when Mani was describing industrial automation, and you are leading a team of software engineers who is going to actually do that layer 0, 1, 2, 3, 4, 5 that he talked about, somebody has to understand the problem that a paper mill has and conceptualize the software which goes into each of those layers, interface with the end customer, in which this case the paper mill owner may not know anything about software, but you now have to interface with the software team that you lead and the paper mill owner and maybe the industrial automation engineer, and draw the blueprint of what is it that needs to be done. So this is one kind of a next level capability which some people call architecting the solution, or solution engineering, or design engineering, and so on, which is a capability. So you might be doing this after 5 years of learning programming, testing, etc., etc. You might graduate to the level where you're actually blueprinting a solution. Once you've blueprinted the solution, somebody has to then assemble the team of engineers and actually make sure that that solution reaches the field. It may be deployed in a plant, or the Mangalyaan rocket has to take off, or a bank has to offer the solution to their customers, or a product has to be released by Google or Facebook or TCS or whatever. There are deadlines. There are things to manage a team so that 10 people, 50 people, 100 people, sometimes 1,000 people work towards that particular goal, and the end product gets then finished and delivered. So there is a project management skill or a program management skill which comes in.